Today's focus is the modeling with sinusoidal functions. We're looking at sine and cosine curves, but we're going to do some review so that you can see exactly what kind of work you need to be putting in to this assignment as you complete it. So let's do a little review first. This is what the sine function looks like. Look at it, starts at the origin 0, 0, and then we got this continuous curve. It's got this midline at y equals 0, which is the x-axis. The amplitude is just how tall that goes, and the amplitude for the basic sine curve is 1. And then the period is from peak to peak, which in this case for a sine curve is 2 pi. Now let's look at the curve for this equation, and you'll notice that it's quite different. We have that midline is y equals 3. Oh look, there's that 3. We have the amplitude going up from halfway between the bottom and the top, but from that midline up is 2. There's the 2. The period is now just pi over 2, which is going to help me be able to figure out that that number right there is 4. And then it's not starting at 0, 0. It's shifted over here to 1, 3. There's that 1. Okay, so let's now be more specific about this. So now here's that curve again. We got all that information. A is the amplitude. There you go. Amplitude is 2. Boom. There it is. C is this horizontal shift or phase shift. If the C is a positive number, that means I shifted to the right. If the C is a negative number, I shifted to the left. Keep in mind that it's x minus C. I subtracted 1, which is positive. That's why it shifted over here 1 to the right. D is the vertical shift, so I'm either going up or down. If D is positive, I'm going up from the x-axis, or if D is negative, I'm going down from the x-axis. And so I have y equals 3, which is my midline. There's my 3. And then the period is equal to 2 pi divided by b. Well, b is this number right here. It's 4. Okay? Now let's do the same thing with cosine, and it's very similar. Difference again is cosine starts at 0, 1 rather than at the origin. We still have that same midline at the x-axis, y equals 0. Amplitude is still 1. And period is still 2 pi. Now again, let's look at this function, and you'll see it's quite different. I've got my midline is at y equals negative 4. There's my minus 4 right there. My amplitude is 3. Now this amplitude is the absolute value, so I've got negative 3 here in this particular function. My period is pi when I do the math, and that helps me to figure out that value right there for b. Okay, so now let's look at this curve and be more specific. Absolute value is amplitude. So my amplitude is 3. But because this curve is flipped over, I have negative 3. Same deal with the horizontal shift, horizontal or phase shift. All right. I'm at 1 plus 1, meaning that I'm shifting left. Well, I shifted left over here to negative 1 right there, because that's going to be my starting point. My midline is D, negative 4. There's my negative 4. And then again, the period is 2 pi divided by b. Well, that's how I got my 2. If I do 2 pi divided by 2, I get a period of pi. Now let's look at this curve. I don't have the numbers. Let's figure out the numbers. Okay? So I want to be able to plug all these values in to this equation. I need the numbers. So if I'm going to get amplitude, I'm going to take the max y minus the min y and divide that by 2. So there's my max y value is at 1. My min y value is at -3. So I did that. 1 minus -3 divided by 2. And I get 2 for an answer. There is that value for A. I'm going to jump down and do D right now. So my vertical shift is going to be the average of those two, of the max y and the min y. So I'm going to add those two together. So I'm going to do 1 minus 3 this time and divide that by 2, and I get -1. So my midline is -1. There it is. And there's that -1 in the function. There's my amplitude as well. Now I'm going to look at the period. Okay, so I'm looking at this from here, bottom to bottom, or peak to peak, and I'm just going to do the math. I'm going to take the larger one and subtract the smaller one to get the distance between those two values. And I end up with 2.095 approximately. And so now I need to find out what b is. Well, if that period is equal to 2 pi divided by b, that means b is equal to 2 pi divided by the period. And so when I do that math, I get 3, very close. Boom, there it is. And now I just need to get c, and to get that phase or horizontal shift, I'm going to take the max x and add it to the min x and divide that by 2. So there's the max point, there's the midpoint. I'm going to take the x values this time and add those together. So I did that, 0.712 plus -0.336, and divide that by 2, and I get 0.188. There we go. I have now completed that function. So you're going to want to keep track of these steps to be able to take that graph and write the function for it. Now we're going to talk about what do you actually need to do in this assignment. And read carefully. That's going to be number one. Please read carefully. And right off the bat, it tells me that we're going to use a cosine function. This is related to a cosine function, so you need to keep that in mind. And so now we're just going right down through. You're looking to get this information right here, A, B, C, and D. That's your goal. And so for part A, it says, what's the phase shift? So you're going to show the work to determine C, just like I showed the work just a moment ago in my example. Same thing for B. Show the work to determine what D is, what this value is. Okay? So again, just like I showed you in my example. We get to here, C, D, and E. Well, for C, what's the amplitude? So you're finding A. Show the work again. For this part, for D, show your work to determine the period and B, just again like I did in my example. I showed you how I figured out what the period is, and I showed you how I used that number to solve for B. And then once you've got A, B, C, and D done, now it's just a matter of writing the equation. You have all of these numbers already. You've already determined them. It's now just a matter of plugging them in to that function. Okay, part one, problem two. We're talking about a sine function this time, and then they give you these 2 points. They say this is a minimum point, this is a maximum point. All right? And again, you're going to take that information, you're going right down the list. Show the work to determine D. Show your work to determine A. Show your work to determine period and B, and again, you just follow the steps that I've already shown you in my example. And then at that point, you're just filling in the information for this function. You'll have the numbers that you need. Now we're going to part two. You're given this table of information. You're given these 12 ordered pairs, and then they give you a graph on here. And so part A says make the scatter plot of the data. So you're actually going to draw the points on this graph. Or if you want, you can use something like Desmos and take a screenshot of that graph and insert that into your document. For B, just state exactly what's that minimum temperature. For C, just state exactly what's that maximum temperature. That's all you need to do for those. And now here we get going with the work that you're going to refer to my example if you need to. So you're showing your work to determine that value of D. You're going to show your work to determine that value of A for the function. You're going to show your work to determine period and B. Remember, B goes into the function. You're going to show your work to determine C. And then at that point, you have all of the numbers to plug it in. So this one, all you're doing is going to write the sine function. You have the values for A, B, C, and D. And then for part I, you're going to use the function that you just created, and you're going to show the work to determine the answer to this question right here. For part 2, problem 2, they give you this information about analog and digital signals. All right, and they give you a couple of graphs, and here's a question that you want to answer for yourself. When you look at these graphs, what do they look like? Do they look like sine curves or do they look like cosine curves? You want to have that answer in your head as you work on the rest of the problem. Because there are only two pieces to this. One, the first one is, why would this one produce a better signal? And again, you're just going to write a sentence or two to explain why sample 2 is better than sample 1. Now part B says write the sinusoid model, meaning write the function. What does that mean you need to do? Show all of your work to determine A, B, C, and D. And then it comes back to the question that I asked, does it look like a sine or does it look like a cosine function? Because you're now going to write the function for this curve, because you now have these values. It's just a matter of plugging them in. And at that point, yes, you are done. Nice work by you.